Good afternoon, all. I hope the screen is visible to you and I am also audible to you. Please reply so that we can start.
Yes, sir.
Okay. In the last lecture, we have started with the syllabus. We have started with the unit 1, whose title is Introduction to Hydrology and Precipitation. So in the last lecture, what we have covered about the definition of the term hydrological cycle, and we have covered various phases of hydrological cycle. Okay, so this is the definition of the term hydrology. Hydrology is what? It is a scientific study of movement, distribution, and quality of water on Earth. It is the study of movement of water from Earth, ocean, and inland water bodies and atmosphere. So this point we have discussed in previous lecture. We have discussed what is the importance of the resource water on the surface of Earth. We know that everywhere there is a scarcity of water, water which is good for the irrigation purpose or for agricultural purpose or for drinking water purpose, for domestic use. So for such a water, everywhere there is a scarcity. There is a mismanagement of the resource water on the surface of Earth. So that's why there is a need of the study of the subject water resource engineering. Okay, and that's why for your syllabus the subject is included, and this subject is divided into two parts. One is hydrology, other is irrigation, and the part 1 is included in your first subject, that is WRE 1. So it is requested that all of you should join the meeting within time, because every time I have to check and I have to add a particular student. So it is a time consuming process. So all of you are asked to join within time. Okay. Then we have discussed about hydrological cycle consists of three important phases: precipitation, evaporation, and runoff. And before runoff, we have discussed about the term infiltration and percolation. So these points we have covered already in previous lecture. So in evaporation and transpiration, we know that this evaporation and transpiration process takes place from the surface of Earth crust. Evaporation takes place from inland water bodies and ocean. Evaporation takes place from plant and leaves. Just a minute. Okay, so we are talking about the evaporation, first important phase of hydrological cycle. And we know that this evaporation takes place from surface of earth. Evaporation takes place from inland water bodies and ocean. It also takes place from the plant, that is from the leaves of the plant. Evaporation takes place also from the atmosphere. We know that this atmosphere is having air mass, and this air mass absorbs moisture in this evaporation process, and again that absorbed moisture gets evaporated due to heat energy. So these are various ways from which the evaporation and transpiration takes place. Then the second important phase of hydrological cycle is precipitation, which is denoted by P. And precipitation is what? It is a fall of moisture from atmosphere, and based on the temperature at that height, the fall of moisture may be in solid form or maybe in liquid form. Then next term is runoff. Runoff is what? It is a part of rainwater which ultimately reaches to the water bodies. So runoff is of three types. First is surface runoff, second is subsurface runoff, which is also known as interflow, and third is groundwater flow, or it is also known as a base flow. Okay, so these are the types of runoff. So we have discussed in detail about all these three important phases of hydrological cycle. Now let us know about the hydrological data. So every time we use the word the data is collected in the hydrology, and that data is known as a hydrological data. And what this hydrological data consists of? This hydrological data consists of the meteorological data. Okay, the first type of data is meteorological data. What is meteorological data? Meteorological data includes the data of daily temperature, wind velocity, humidity. So all these weather parameters, they are recorded, and that data is known as a hydrological data. And for that there is a Indian Meteorological Department. So if you search on a Google IMD Mumbai and IMD Pune, there are two separate sites for these two meteorological department. And on these sites, you can see the daily recorded temperature. Just a minute. So we are talking about the meteorological data. So this meteorological data is available on the Indian Meteorological Department site. Okay, there is a IMD Mumbai and IMD Pune. There are two separate sites on which this data is available. Along with that, this Indian Meteorological Department issues warnings regarding the rainfall, snowfall. Also, it issues warning related to the cyclones. Okay, so if you register your number on that site, then occasionally you will get alerts for the heavy rainfall or for cyclones. Okay, so this is the first type of hydrological data. that is known as a meteorological data. Second is a precipitation record. So you know what is precipitation? It is a fall of moisture in the form of either rainfall or snowfall. Now this precipitation record is available on daily basis. Now this record is maintained by the agricultural ministry, agricultural department, and that is backed up by the revenue department. So there is a revenue department, and that revenue department actually collects and keeps the data, and that data is available with the agricultural department also. So if you visit the Maha Agri website, okay, name of the website is Maha Agri. So on that website, daily rainfall values we can see, daily rainfall. Okay, also the last year record is available. Also the normal annual rainfall values are available. So you can check what is the normal annual value for a particular date and what is today's rainfall. So we can compare these two values, whether the today's rainfall is greater or lesser than the normal annual rainfall value of that date. So in practicals, we have discussed about the normal annual rainfall. Okay, similarly, this normal value can be calculated for a particular date. And then it is said that today the rainfall is 10% less than the normal annual value. So this record, so all of you are asked to check that Mahagiri website, and in that go to the precipitation record, and every day, and also the last 7 days rainfall data is available on that. The same data is also available on IMD site, but this particular Mahagiri site is especially for the agricultural purpose, and on that site the detailed information of rainfall is available. Along with that, on this IMD site, various graphs are shown, past record is shown, the track of monsoon wind is shown. Okay, the journey of monsoon is also shown. So that is available on that IMD website. Okay, so precipitation record is one of the hydrological data. So there is a record available in a tabular form. Also, it is available in terms of maps. Okay, based on the rainfall magnitudes and based on rainfall intensities, these maps are generated. So precipitation record, hydrological data. Then stream flow record. Now, what do you understood from stream flow record? That we know in last lecture I have explained you regarding the term hydrograph. So what is hydrograph? It is a graph plotted between discharge versus time. Okay, this graph is a hydrograph. This hydrograph is plotted on the basis of stream flow record. Okay, on x-axis, on y-axis discharge, and on x-axis time. So hydrograph is a graph between discharge versus time, and this discharge is obtained from stream flow record. Now, how this stream flow record or discharge is measured? So for that, a catchment area is considered. Suppose this is one catchment area, and this is the biggest stream, and this is the outlet of the stream from the catchment area. So at this point in the stream, a permanent gauge is established. Okay, some rocky terrain is selected in the stream. So purpose of selecting a rocky terrain is to have firm cross section. Okay, so it will not change with the time, or the change is very minor in that case if it is a firm strata. So firm cross section is selected, and then a cross section is plotted by taking measurements. The width of cross section, then the depths are measured, and from that the cross sectional area is worked out. And after that the velocity is worked out. So this is how the discharge is measured in a stream. Okay, so stream flow record is a discharge of water or discharge of runoff in a stream. Okay, so this stream is the stream at the outlet of the basin. Okay, so what is basin or watershed? It is explained to you in previous lecture. Okay, such a sketch I have shown to explain the watershed, and this is the outlet point of watershed. At this point discharge is measured, and this discharge is measured for suitable interval of time, and then this graph is prepared, hydrograph. So this is a stream flow record. What we get from stream flow record? From stream flow record we get maximum discharge. What is the peak value of the discharge that we get? So peak value is generally a flood value. Okay, so that is the importance of stream flow record. So if such a record is available, then by referring that record, we can prepare unit hydrographs, or we can predict what will be the maximum probable flood due to similar such a storm in future. So this is stream flow record. Now next is evaporation data. So evaporation data, yesterday I have explained that this evaporation is measured in millimeter per day. What is the evaporation loss in millimeter per day? So for that certain instruments are used, and this evaporation is measured. This evaporation is measured near to the large water bodies. If there are lakes or dams which are having higher area which is exposed to the atmosphere, in that case the evaporation losses are more. It is observed that in South India the evaporation losses in case of lakes is around 30% of total water storage capacity. So that is the importance of evaporation losses in the reservoirs and lakes, and that's why evaporation data is important. So evaporation data is again a part of hydrological data. Next is water quality data. Now this water resource engineering or hydrology and irrigation, they deals with providing water to the human beings either for domestic purpose, for industrial purpose, or for agricultural purpose. So in all cases, what is important? The quality of water is important. So in hydrology, the water quality data is also maintained. Okay, so various sources are considered, and what is the quality of water available in these various inland sources. So that data is maintained. So water quality data is again a hydrological data. Next is geomorphological studies of the basin. Now, what do you mean by geomorphological studies of the basin? At first, what is basin? Basin is watershed. So this sketch is basin. Okay. So yesterday I have explained you that this is known as either basin or watershed, or it is known as a drainage basin. There are so many terms for this figure. So there is one more term, catchment area. So this is basin. So I have drawn here 2D figure. Okay. So here we don't get any idea about the geomorphology of the basin. So what is geomorphology of the basin? Geomorphology means it is the study of the area, the shape of the basin, then slope of the basin. So it deals with the study of topography of the basin. Okay. What it includes: area, shape, slope, and elevations in the basin. So that is known as a geomorphological characteristics of the basin. So in hydrological data, geomorphological characteristics of basin are also provided. Now, entire our country is divided into number of such basins. Okay, these basins are mainly classified on the basis of river. Okay, on the basis of major rivers in India. For example, Krishna River. So there is a Krishna Basin. Krishna Basin includes the main Krishna River as well as various tributaries which are feeding to the Krishna River, and the area adjacent to them which is feeding these tributaries. For example, the Panchaganga River that feeds water to the Krishna River. So Panchaganga is a tributary of Krishna River. So Panchaganga River is having its own basin, is having its own catchment area. So catchment area of that river is feeding water to the Panchaganga River. And there are number of such rivers which feeds water to the Krishna River. So all these tributaries are having their own catchment area, and collectively there is a catchment area for Krishna River basin. Okay, so that is meaning of the term basin, watershed, or catchment area. And geomorphological study is study of all these characteristics: area, shape, slope of the basin, elevation of the basin. So in short, it is the study of the topography of the catchment area. So that record is also maintained in hydrology, because based on that we came to know what will be the runoff. If we know rainfall values, rainfall magnitudes, in that case from that we came to know about the runoff values based on these geomorphological characteristics of basin. Now, along with this, hydrological data also possess some maps like isohydral maps. Isohydral map is similar to that of contour map. All of you are familiar with the contour map. We know that the contour line close upon itself. Okay, not necessary within the boundary of the map. Then contour line, the distance between two contour lines, horizontal distance, that is known as a horizontal equivalent. Distance between vertical distance between two contour lines is known as a contour interval. So this isohydral map, and what is contour line? Contour line is a line joining points of equal elevations. Suppose this is a contour of RL 100 meter. So what is meaning of this? If we consider any point on this line, then its elevation is 100 meter. This is about contour. So now there is a term isohydral line. Okay, these isohydral maps, they are consist of isohydral lines. So what is isohydral line? Isohydral line is a line on a map which connects the points of equal precipitation. Okay, points of equal rainfall. So such a line is known as an isohydral line. And isohydral map is a map consists of number of such isohydral lines. Okay, from this isohydral map, one can get idea about the intensity of precipitation or the amount of precipitation in a particular area. So that is the importance of isohydral maps. Isohydral maps consist of number of isohydral lines. Isohydral lines are the lines joining points of equal precipitation in the area. So isohydral maps are also prepared in hydrological data. Okay, so when we say the term hydrological data, then it consists of all these things: hydrometeorological data, sorry, precipitation record, stream flow record, evaporation data, water quality data, geomorphological characteristics of the basin, and isohydral maps. Now, let us discuss about the scope of the subject hydrology. Okay, so the first point which explains the scope of subject hydrology is, in hydrology we get the maximum probable flood value. Now all of you know the importance of flood or the drawbacks of flood. Okay, so you know, due to flood there is a loss of life and property, and this year we have experienced a devastating flood all over the world. So what is the role of hydrology? In hydrology, the stream flow record is kept. Okay, from stream flow record, what we get, we have seen in previous slide. In stream flow record, we get the maximum discharge, peak flood, Q max. Okay, so Q max we get. So to calculate this maximum probable flood, what is done? The maximum flood discharge record is checked. Okay, and in that the most severe and worst flood is selected. Okay, the maximum value is selected. So that value is maximum probable flood. To find out the value of maximum probable flood, it is assumed that there is a worst combination of all meteorological parameters. Now, which are the meteorological parameters due to which rainfall occurs? First is the heat energy, okay, solar radiations. Second is wind direction and wind velocity. Okay, third is humidity, okay, relative humidity of the atmosphere. So all these meteorological parameters are considered. Their worst combination is taken into account, and due to that, the maximum peak discharge value is generated, and that value is known as a maximum probable flood. And this particular value is used to design various structures such as culverts. So do you know what is culvert? Culvert is a small bridge constructed on the roads. Okay, many times very small streams crosses the road alignment. In that case, small bridges are constructed. Okay, so 2-3 pipes are used, and then above that the road is constructed. So such a small bridges on the road where natural small streams crosses, that structure is known as culvert. So during design of culvert, again this maximum flood value is taken into account. Then dams and reservoir. Now during design of outlet for the dam is known as spillway. The spillway is component of a dam which spill off the excess water. So to design spillway, this value of maximum probable flood is taken into account. Okay, that is the importance of the calculation of maximum probable flood value, Qmax. Then in design of dams and reservoir, again this value is important. So from this, it is possible to find out how much quantity of water is going to collect from a storm or from a year. Then canals. Again, for design of canals, this value is essential. Similar to roads, these canals again crosses the natural drains in the area, and at the crossing some hydrological structures are necessary, and to design these structures in that area maximum probable flood value is essential. So that is the importance of, yes. कोणाला काही विचारायचं का? कोणतरी बोललं मध्ये? If you have any doubt, you can ask without any hesitation. So we are talking about maximum probable flood. Okay, we have completed that point. Now, second point is water yield of basin. Okay, basin, now it is clear to you what is basin or catchment area. Now, what is the yield of basin? What do you mean by yield of basin? Yield of basin is the quantity of water which is available from the basin in a particular season or in a particular year. That is known as water yield. Okay, yield is nothing but output. How much quantity of water can be collected from this particular selected basin, selected catchment area. So this value is worked out in the study of hydrology, and this value is important in design of dams. Suppose a dam is proposed in a catchment area, and suppose the capacity of dam is 100 TMC. And if after hydrological study of the basin, it is found that the water yield of the basin is only 80 TMC. So it is of no use to construct a dam with 100 TMC capacity. Is it clear? So to decide the capacity of dam, the water yield of basin is important. So this is how hydrology helps in design of dams. Then water supply. Okay, so now we know that for large cities in India, the water is supplied from dams directly instead of the locally available river. A permanent source of water is selected as a reservoir or dam. For example, for Solapur city, water is supplied from Ujni Dam. Okay, now for Kolhapur, the work is going on to supply the water from Kalamwadi Dam. So if the dams are designed as a multi-purpose reservoirs, in that case, the amount of water required for water supply is taken into account. Okay, so for design of water supply schemes, again, the water yield of basin calculation is important. Water power. We know that when dams are built, then at the feet of the dam, hydroelectric power plants are established, and through that the power is generated. So, and that is known as a water power. So water power is very important or crucial in the development of the nation, and that again depends on what is the yield of basin. By fulfilling the required demand, if excess water is available from the basin, then water power stations are planned. And last point is river navigation. So if we know what is the yield of basin, then that water can be regulated in the river for navigation purpose. What is river navigation? River navigation means it is the movement of goods and peoples through the rivers. And for river navigation, a certain depth of water is always essential. Okay, then only the navigation is possible. So in order to maintain a particular depth of water in the channel in the river, there should be sufficient water in the dam, and to have a sufficient water in the dam, there should be sufficient yield of the basin. So yield of the basin affects the capacity of dam, then water supply schemes in the area, then it affects the power generation, and also it affects the navigation in the river. So navigation in the river is known as a inland navigation, and other is seaborne navigation. So for all these purposes, water yield of basin, this value is important. Okay, its occurrence and what is its quantity and frequency. Sometimes yield is so large that dam can be filled 2 times or 3 times in a year. Such yield is also available. So accordingly, the dams are planned. Okay, this is about water yield of the basin. Then next is maximum intensity of storm and its frequency. So you know about the the term intensity. Okay, we have discussed about the term magnitude of precipitation. Now magnitude of precipitation is expressed in centimeter depth of water or millimeter depth of water. Opposite to that, intensity of precipitation is expressed in centimeter per hour or millimeter per hour. Is it clear? It is expressed as centimeter or millimeter per hour. Okay, and during design of drainage projects, this maximum intensity of precipitation, this value is essential. Okay, if I say intensity of precipitation is 10 centimeter per hour, it is expressed as centimeter per hour. Just a minute. Suppose it is, take example of intensity of precipitation, 10 centimeter per hour. Okay, and intensity of precipitation is suppose 20 centimeter per hour. And suppose duration of storm. Duration of storm. Storm म्हणजे काय? It is a session of rainfall. Is suppose 4 hours. Okay, duration of storm is 4 hours. Now in this case, if the intensity is 20 centimeter per hour, then in 4 hours, what will be the total rainfall? For each hour it is 20 centimeter. So what is for 4 hours? Please reply. See what example I have given. The intensity of precipitation, intensity of rainfall is 20 centimeter per hour and duration of rainfall is 4 hours. So what is total precipitation in 4 hours?
80.
Correct. It is 80 centimeter. Okay. And if the intensity is 10 centimeter, in that case, in 4 hours, it is 40 centimeter. Is it clear? So what is the relation between intensity and magnitude of precipitation? So intensity of precipitation is equal to magnitude of precipitation upon time. Is it clear? 10 centimeter per hour. Okay, and if we have to calculate total precipitation magnitude, then how we get intensity into time? Okay, so here intensity is 10 and time is 4 hours. So that's why this is 40 centimeter. Here intensity is 20 and time is 4 hours. It is 80 centimeter. So that is difference between the total magnitude of precipitation and intensity of precipitation and its frequency. Suppose in a day, the first storm occurs for 4 hours duration. Suppose second storm occurs of say 5 hours duration. So how many times storm occurs? So if this data is available, then that is helpful in design of drainage projects in the area. So what is drainage project? Okay, drainage project consists of drainage lines. Okay, drainage lines are actually planned for what? They are actually planned for the wastewater in the area, to carry the wastewater in the area. For that drainage projects are planned. But when they are planned, then at that time during planning stage, this stormwater discharge should also taken into account. Is it clear? So they must be capable of carrying stormwater along with the wastewater. So during design stage, during design of drainage project, this stormwater quantity should be taken into account. Instead of quantity, the intensity of storm should be taken into account. Suppose 80 centimeter rainfall takes place and it takes place in 24 hours. Then the flood is not created. But if 80 centimeter rainfall occurs in 4 hours or 2 hours, in that case flood situation may occur. So to avoid this, maximum intensity of storm is taken into account and also its frequency is taken into account. And this data is a hydrological data, and this hydrological data is used in design of drainage projects in the basin or in a particular area. So that is the importance of the subject hydrology. Okay. So after studying the details of hydrology, now let us come to the second important point or second sub point of unit number 1, that is on precipitation. So the term precipitation is denoted by capital P, and precipitation P is known as it is the fall of moisture from atmosphere. And based on the form in which the moisture falls from the atmosphere, there are various types. Okay, so which are the forms of precipitation? First is a drizzle, second is rain, third is glaze, next is snow, next is snowflakes, then hail, dew, frost, fog, mist. So many terms are familiar to you. So can you tell me what do you understood from the hail? Hail माहिती आहे का तुम्हाला? Okay. Are you familiar with the dew? Dew तरी माहित आहे का तुम्हाला?
सर दवा बिंदू ना?
करेक्ट. सो ड्यू म्हणजे दव जे पडतं त्याला ड्यू म्हणतो आपण. ओके. आर यू फॅमिलियर विथ द फॉग?
सर धुक्क ना?
करेक्ट. फॉग म्हणजे धुकं. ओके. Then you are familiar with the rain and snow also. Okay, now we'll discuss all this one by one. So first is drizzle. What is drizzle? So a light steady rain in the form of fine drops, and these drops are having size less than 0.5 mm, and if we go for intensity, then intensity is less than 1 mm per hour, then that precipitation is recognized as a drizzle. A light steady rain is drizzle. Okay, and here the raindrops are having size less than 0.5 and intensity less than 1 mm per hour, then it is recognized as a drizzle. Then the moisture is recognized as a rain when the raindrop or water droplet size varies from 0.5 mm to 6 mm. Okay, then it is recognized as a rain. Next is glaze. So what is glaze? Freezing of drizzles or rain when they come in contact with the cold object, that is known as a glaze. See, when drizzle or rainfall occurs and when that water accumulates over the cold metal surfaces, cold objects, then the freezing takes place, and then that freezed water droplets, they are recognized as glaze. Next is snow. So when water vapors condense to the ice, when they detach from the clouds, at that point only, when they condense to the ice, then it is known as a snowfall. When the snowfall takes place and when the ice crystals are fused together due to some media, then it is recognized as a snowflakes. Okay, so it is clear to you what is drizzle, rain, glaze, snow, and snowflakes. Also, after this I will show you the pictures of all these forms of precipitation. Next is hail. Hail म्हणजे काय तर गारा. So what is hail? Hail is small lump of ice whose diameter is greater than 5 mm And how these small lumps of ice are formed? They are formed due to alternate freezing and melting. When they are carried up and down in highly turbulent air currents, this process takes place. Alternate freezing and melting of water drops takes place in the air due to highly turbulent air current at higher altitudes. In that case, small lump of ice is formed whose diameter is generally more than 5 mm. So that is known as a hail. Next is dew. So what is dew? Dew will happen the month. But what is dew actually? Dew is moisture condensed from the atmosphere in small drops on cold surfaces. What is frost? When dew temperature is less than 0 degrees Celsius, then frost is formed. Is it clear? Now this dew, where we can observe this dew? Dew आपण कुठं बघतो दव? So generally we can observe this dew on the grass. Okay. So when the moisture from the atmosphere is condensed in a small drops, then it is known as a dew. And when they are condensed, if the temperature is less than 0 degree, then instead of water drops, that moisture from atmosphere is converted into ice crystals, and that is known as a frost. When dew temperature is less than 0 degrees Celsius, frost is formed. Then there is a term fog. What is fog? Fog is a thin cloud of varying sizes formed at the surface of Earth by condensation of atmospheric vapor. Okay, the fog is not a fall of moisture from the clouds. Okay, fog is a cloud which is formed on the surface of Earth by condensation of atmospheric vapor. Atmospheric vapor means what? So atmosphere consists of air masses, and these air masses absorbs water vapors. Okay, due to evaporation, water changes from liquid to gaseous state. Water vapors are formed. These water vapors are absorbed by air masses. So they are available in the air masses which are close to the earth surface or which are close to the water surfaces. So moisture available in the atmosphere, when it is condensed, a thin cloud is formed. Okay, and that is known as a fog. And when this fog is very thin, then it is known as a mist. Okay, there are two terms, mist and fog. Okay, they are similar, but mist is what? It is a very thin fog. Okay, I hope you understood all these terms. Now we will go through some of the pictures of these forms of precipitation. So on the screen now you can observe the four pictures. The first picture shows rainfall. The second picture shows snowfall. Third shows snowflakes. When ice crystals are fused together with some medium, then these are snowflakes. Next is a frost. Okay, see, hail. then frost, okay, then dew. And these next two pictures shows the fog and mist. Okay, based on this in the exam, the question is asked, define the term precipitation and explain the forms of precipitation. So you have to write definitions of all these terms. Okay. So with this today, let us stop here as time is up. In next lecture, I will explain you various types of precipitation. You know how precipitation takes place. At first, evaporation takes place. During evaporation, water vapors are absorbed by air masses. When air masses reaches to certain saturation capacity, then these air masses are driven away from the area by the wind action. Then due to various processes, these air masses gets lifted at higher altitude in the sky, and after that, when these clouds reaches at higher altitude, they come in contact with the cold atmosphere, and as there is a reduction in temperature, at that point condensation process takes place and rainfall takes place. So what you understood from all this, the air masses are moved from one place to other. They are moved from one height to other. They are moved at higher altitudes. And all this process is carried out by the winds. And based on how these air masses are lifted to higher altitudes, based on this, there are various types of precipitations, such as thermal or convective precipitation. Second is frontal precipitation. Third is orographic precipitation. And fourth is cyclonic precipitation. So in the next lecture, I will explain you in detail about all these types of precipitation. So with this, let us stop here.